Right. So in today's session, we'll be discussing about the Hadoop architecture. As per the definition of Hadoop, it's an open source software framework completely written in Java to handle big data, right? Big data is again three V's. What are those three V's? Perfect. Now, when you install Hadoop, it comes with two components. One is storage part, and then the other one is processing part. Storage part is known as HDFS. Processing part is known as MapReduce. Now, in this session, we'll be discussing about the storage part of Hadoop, how we can store large volumes of data in Hadoop distributed file system. The name itself says Hadoop distributed file system, which means the files are not stored on a single server. The files are stored on a group of machines, distributed across a group of machines, right? So as per the definition, Hadoop distributed file system means HDFS is a specially designed file system used to store large volumes of data across a cluster of commodity hardware machines for streaming data access. The definition says that it is a specially designed file system used to store large volumes of data across a cluster of commodity hardware machines for streaming data access. Let's divide this definition into three parts. One is specially designed file system. Okay, and then cluster of commodity hardware machines and streaming data access. So this definition can be divided into three parts. One is specially designed file system. The other one is cluster of commodity hardware machines, and third one is streaming data access. So why Hadoop is known as a specially designed file system? You have a Linux file system, you have a Windows file system, right? So in Windows, you store the data. For example, in C drive and D drive, you have data, right? In Windows, normally you store the data in your drives, C drives and D drives. Now in Windows or in Linux, there is a concept called segmentation. Please understand the topic first, okay? There is a concept called segmentation. How the internal memory has been divided. Suppose I open a notepad, for example, let us assume that I have opened a notepad. I've given some data. Now, if I want to store this file, what I have to do? I need to save, right? Then it will ask me to which name I need to save that file. You need to give ABC or something, any file name, sample file. Once I give that file name, it will automatically save, right? You close it. Now, as an end user, we are the end users, we are creating files, we are entering the data. Now, once the file is closed, that's it. Our task is completed. So internally, what happens, you know? The internal memory is divided into small cells called segments. And each segment can handle up to 4 KB to 8 KB. Some segments can store 16 KB file size. Now my file size is, say, for example, 2 KB. So it will store in this first cell. Though it has the capacity of storing 8 KB, the notepad is taking only 2 KB. Suppose I have stored another PDF, which is some 16 KB. Now this is 8 KB taking complete size, 8 KB and again taking complete size. Next 10 KB, 8 KB and again here 2 KB. Likewise, the size of the file is divided into segments. If you see the first segment, though it has the capacity of 8 KB, the file size we have stored is only 2 KB. Remaining 6 KB is not utilized completely, right? Rather, it is wasted. Likewise, more number of files you do, there will be some cells who is taking complete 8 KB, whereas few cells are not taking complete cells. When it comes to Hadoop, why we are calling it as a specially designed file system is the input data that you are submitted to Hadoop cluster is divided into smallest units of chunks called blocks. In Hadoop, we have the terminology called blocks. The data is referred to as blocks. Okay. No matter. And again, we discussed that Hadoop is mainly for small number of large files. Whenever you are required, we opt for big data, right? So in this case, no matter how big the file is divided into small units of chunks called blocks, and each block is default size of 64 MB. Hadoop 1.x version MB. So if anyone asks you what default means, whether you mention or not, you have the customize, you can customize as well as per your convenience. But 128 block size is fixed. What framework decides? Okay. Now say for example, I have for our understanding 100 MB file. If you take the default location as 64 MB, I mean default block size as 64 MB. How many blocks it will be divided? 2 blocks, right? One is 64 MB, the other one is 36. Perfect. 36 MB. Even though it has the capacity of 64 MB. So this can be calculated as B1, B2. If I want to store the same 100 MB file in this Windows or Linux, it should be divided 1 MB equals to 1024 KB. So 100 MB means 100 into 1024 KB. And again, file size 8 KB. Say for example, 100 or 200 segments it will store. But when it comes to Hadoop, it is storing only 2 blocks, right? Now, for example, 128 MB. How many blocks? 6. Considering default as 64, not 128. We are just discussing 1.x, right? So consider as 64 MB as of now. Okay. So 2 blocks. One is B1, B2. Here in this case, B1 and B2 are completely taking 64 MB. Let us take 200 MB. How many blocks? 180 plus 12, 192, 8. 300 MB. 128, 128, 256, and then 44 MB. So total how many? B1, B2, B3, B4, B5. 400 MB. 64, 64, 64, 64, 64, 64. 1, 2, 3, 4, 5, 6. 360 plus 24, 384. And then 16. So total how many blocks? B1, B2, B3, B4, B5, B6, B7. 500 MB. 64, 64, 64, 64, 64, 64. 1, 2, 3, 4, 5, 6, 7. 7, 6, 42. 7, 4, 28. Oh. Come here. Okay, 420 plus 24. How much? 1, 2, 3, 4, 5, 6, 7. 420 plus 28. 448. 52. So total how many blocks? B1, B2, B3, B4, B5, B6, B7, B8. So no matter how big the file size is, it will be divided in the order of blocks. Now, from this observation, you can come to your mind that if there are n blocks, right? If there are n blocks, n minus 1 blocks are always equals to default block size, right? Take for example, last, how many blocks are there? 8 blocks. So n equals to 8. N minus 1, 7. So total B1, B2, B3, B4, B5, B6, B7. 7 blocks are always taking 64 MB, complete block size. If you see B7, n equals to 7. N minus 1, 7 minus 1, 6 blocks are always equals to default block size, right? Likewise, B3, B4. If you see the second one, both B1 and B2 are equal. So the last block may or may not equals to default block size, but n minus 1 blocks are always equals to default block size. Are we clear on this, everybody? Here in this case, beautiful question. This case, unlike Windows or Linux, here if you see 36 MB, 28 MB is there, right? It's not wasted. The framework will take care of this file system and it will assign the remaining space to other small files. For example, here it is 8 MB or something is there left over, right? It may assign to that file, which is again considered as one block, depending upon the data node hard disk. I'll tell you with a simple one example. Till now, are we clear? Right. Now, specially designed file system. So this is one of the future of specially designed file system where the input data is divided into smallest units of chunks called blocks. Correct. And why we are storing this data? Where we are storing? Used to store large volumes of data across a cluster of commodity hardware machines. So what is cluster? Blue t-shirt, blue t-shirt. You know, what is a cluster? Group of machines. Cluster of commodity hardware machines. What is commodity hardware? Inexpensive hardware. Okay, rather you can say cheap hardware. For example, my laptop is there. It's considered as a cheap hardware. 1 terabyte hard disk, 8 GB RAM, and 5 V cores. Why I am considering this as a inexpensive is this machine needs maintenance for every 6 months to 1 year. Otherwise, this machine may encounter so many problems: slow running processes, motherboard issues, heating issues, etc., right? So in that case, if I have not taken care of this machine, what happens to my data here? There is a chance of losing due to unavailability of this machine, right? Now I'm telling that we are storing large volumes of data across a cluster of commodity hardware machines. Means we are storing this valuable data across inexpensive machines. So how reliable is my data is the first point. Understand? Because these are not high-end servers, these are low-end servers. So what happens if my server goes down? How can I get my data? For that, again, first point, specially designed file system. Hadoop, for that reason, in order to keep highly available the data and fault tolerant, it makes a replication of default 3. So what is replication 3? If you want to store 100 MB data in Hadoop, it requires 3 into 100 MB storage. That is 300 MB storage is required. 100 MB B1, B2, right? Now here it will replicate the data B1, B2, B1, B2. 3 B1s and 3 B2s are stored in Hadoop. Right? Not on a single machine. Now don't think that all this data will be stored in a single machine. Whenever we are discussing about Hadoop, these valuable blocks are distributed across different machines. Okay. Now, if I want to store 1 GB data, how much storage is required in Hadoop? 3 into 1 GB, so 3 GB. If I want to store 1 terabyte, 3 terabytes of storage is required in Hadoop. Okay, fine. So we are storing this valuable data across a cluster of commodity hardware. For what purpose we are storing? Streaming data access. What is this streaming data access? Warm architecture. What is warm? Write once, read many times. Once a file is written to the Hadoop cluster, you cannot update the file, modify the file. Rather, you can append the file, right? So once you store 64 MB, it is done. You cannot modify that, but you can read as many number of times. Okay. So the definition says that HDFS is a specially designed file system which is used to store very large volumes of data across a cluster of commodity hardware machines for write once, read many times purpose. In this process, Hadoop is maintaining a replication of 3, a block size of 64 MB. Green. Okay. Now let us see. Till now, are we clear or any questions? Correct. Backup, not replica, means same copy. Not backup. Don't tell it as a backup. A copy. Copy is different. Backup is different. Copy. 3 copies. Dual role, triple roles, right? Likewise, same B1 will be replicated into 2 more machines. B1, B1, B1. Exactly. Yes, if you are appending one file means all that file across the blocks will get appended. Okay. That also we'll see with one example. Change means append, only appending only you can do. No. Appending means adding the data to the last page only. There's a page, there's a book, this is the file. Now you have placed this file into Hadoop. Done. You cannot update this file, but you can add some data to this file. Means all this data will be there. Again, you are adding this data. So this complete file size is again replicated across 3 blocks. Right? We'll do with one example, then you will clear understand. Yes, it will do. Okay. That is the beauty of Hadoop framework is the block assignments and the storage assignment will be taken care by the framework only. You need not worry. You just give the file to store and it will does the all the storage part. Let me show you with one example. Till now we are clear, right? Are any questions on this? Right? Okay. Now, tell. Traditional approach means? In traditional means RDBMS servers, right? RDBMS servers are single centralized servers. Here we are using distributed. Understand the difference. RDBMS means you store all the data in a single server. Here we are storing the data across group of machines. The data is distributed. Even though if say for example, if this machine is down, what happens? The data that is available, that data will not be available to the users. In this cluster, if this machine is down, you still have the data available on remaining machines. So that's why we are going with distributed environments. Moreover, traditional relational database management systems are very costly, and also they can store only structured data only. Structured data. Here in Hadoop, you can store structured, semi-structured, unstructured data, right? The storage part is limited over RDBMS. Up to few terabytes or petabytes only you can store. But whereas Hadoop has limitless storage, you can store gigabytes, terabytes, petabytes, zettabytes, exabytes, yoyobytes, no limit, right? Good. Now say there is one farmer who is cultivating some rice bags or sugar bags. Now there are some 200 rice bags with this farmer. Now he wants to store these rice bags, but there is no enough space in his home. But he wants to store. So what are his possible options? Godowns, market yards, or warehouses, right? So warehouses. Now, so the farmer went to a nearby warehouse. Can this farmer directly go and store all these 200 rice bags in this warehouse? No, right? There must be someone who is in charge of this warehouse. There should be a manager. This manager has the complete information of this warehouse. Now, if I want to check with the rooms, this manager cannot go to each and every room, right? There will be some workers. So from that workers, he will get to know which room is free, which room is completely filled. So once the farmer contacts this manager says, "Hello farmer, how are you? What can I do for you? Or how can I help you?" The farmer says, "I have 200 rice bags. I want to store in your warehouse." So this manager from the workers says that, okay, we have space. And so say, for example, 50, 60, 40, and again 50. Now, once the rice bags are completely stored in these rooms, this manager will give a receipt, name of the farmer, time, date, etc., how many rice bags information. And then the farmer happily takes the receipt, acknowledging it, and he will go. Whenever he wants to get those rice bags, he will show that authentication slip to the manager, and then he can take those rice bags. This is what happens in a transaction, right? If the same scenario is attached to the Hadoop cluster, the farmer in our case is the user who wants to store some data. Suppose I want to store 192 MB, like 200 MB or 192 MB. Whom the farmer is contacting first? Manager, right? So here the manager of Hadoop distributed file system is name node. Name node is the master HDFS daemon. Name node is the master HDFS daemon. Like how this manager is having the complete information of all the rooms and what is the commodities that were stored, the name node has the complete control or complete metadata information of the cluster. The rice bags are stored in the rooms, right? These rooms are nothing but data nodes. Where the data is stored, actual data is stored, is known as data nodes. So here, for example, we have 5 data nodes. For example, data node 1, data node 2, data node 3, data node 4, data node 5. We have 5 data nodes, right? Now, the farmer requests or the user requests name node. How many blocks? 192 MB means default blocks is 64. How many blocks? 3 blocks. 64 MB, 64 MB, 64 MB. So B1, B2, B3. Now this user requests, hey name node, I have 192 MB, which requires 3 block locations from your cluster. Now, how do the name node will do? Before storing, these data nodes are all connected to a cluster, right? Means they are connected over a TCP/IP network, correct? All the data nodes in the Hadoop cluster, every data node should be sending a heartbeat signal to the name node for every 3 seconds by default. How many data nodes? These are all slave daemons. So every data node has to send a heartbeat signal to name node saying that it is up and running. Why? Because these are all configured in a network, right? So there might be a chance of losing the data, losing the connections. So to make sure that they are up and running and connected, every data node will be sending a heartbeat signal to name node, so that name node will know, okay, I am receiving the heartbeat signal from this guy. So he is listening. I am getting the heartbeat signal from this green t-shirt. So means he's listening. I will, like this, name node will be getting the heartbeat signals from all the nodes. If any data node is not sending heartbeat signal, name node will check that mission for some time, like 10 minutes. And after 10 minutes also, the data node is not sending any signal, the name node will mark this node as dead. Means, okay, there is some issue with this node. I should not assign the blocks. Understand the mechanism. Every data node, slave node will be sending a signal to master node saying that I am up and running. From that information, name node will know, okay, which node is running and which node is not running, right? Now, how do the assignment of blocks will take place? Let me open one command prompt. I'm just giving ping www.yahoo.com. So in how much time I'm getting the ping from Yahoo? 122 milliseconds. Means if I want to send any data to Yahoo server is responding in 122 milliseconds. Suppose let's take IBM. Sorry. This is 122, right? IBM is sending signals in how many seconds? 68 seconds. So which is nearer to me? Which server is nearer to me? IBM, right? So if I want to send the data, which is responding fastly? IBM. Likewise, if I do another mission, YouTube. Now it is responding in how much? 72. One mission is responding in 68 milliseconds. One mission is responding in 72. And the other mission is responding in 122. So if I want to send the data, what is the first mission that receives the data? IBM. Next mission is YouTube. And the farthest to me is Yahoo, right? Likewise, name node will be deciding the data nodes according to the sorted network distance. Whichever data node is responding fastly, that will be considered as the nearest data node to the name node. In this case, let us assume that all the 5 nodes are sorted according to the network distance. Means data node 1 is first nearest, 2 is the second, third is the third nearest, data node 4 is the fourth, and this is the farthest. Now I need to store 3 blocks. Name node will have it designs is, take any mission V1. The first rule is no 2 same blocks of the same data set will be stored in the same data node. I repeat, no 2 same blocks of the same data will not be stored in the same data node. So in this case, we have 3 blocks. So if name node is storing V1 here, It will not store another copy because what is the replication? 3, right? So it has to store 3 copies, right? So B1, it may store here somewhere else. Now B2, suppose it has chosen B2 here. Does it store the same copy on the same node? No, right? So it may choose any mission, either this or this. So for our understanding, B2, and final mission B3. For example, it has chosen B3 here. B3, B3, and B3. The data is written. Now you see you have a B1, B2, B3, which is replicated across 5 data nodes with replication 3. B1 is stored on data node 1, data node 2, data node 3. B2 is stored on data node 2, data node 3, data node 4, and third block is stored on data node 1, data node 4, and data node 5. For every 3 seconds, data node will be sharing the heartbeat signals. For every 10th heartbeat signal, 10th heartbeat means how much? 30 seconds. For every 30 seconds by default, every data node will be sending a complete block report to name node. So what is a block report? A block report consists of the list of files, directories, blocks, amount of CPU utilized, what are all the resources that are running. Everything information will be shared by each data node to name node. Like for example, data node 1 will share heartbeat signal after block report. Data node 1 will share, okay, I have block 1, block 3 to name node for 30 seconds. For the same 30 seconds, data node 2 will share name node. I have blocks B1 and B2. Data node 3 will say that I have blocks B1, B2. Data node 4 will say that I have B2, B3. Data node 4 will say that I have, data node 5 will say that B3. From this information, name node will update its metadata as, okay, where is block 1 stored? Data node 1, data node 2, data node 3. So block 1 locations are data node 1, data node 2, data node 3. Where is block 2 stored? Tell me. Data node 2, 3, data node 4. So block 2 is stored across data node 2, 3, and 4. Block 3 is stored across block 3, where data node 5, data node 1, and data node 4, right? So data node 1, data node 4, data node 5. This is the metadata for this 192 MB data. For example, it is a geo data. So the geo data metadata information is stored in this format in name node. It stores in its hard disk. So whenever client wants to read that geo data, it will ask, hey, name node, I want to read my data. Then it will check its information. Okay, geo data is stored under this location. Suppose you store Airtel data. That is, for example, 100 MB. 100 MB means how many blocks? B1, B2. Okay, let's make all those colors into some light colors. So first of all, B1, say for example here B1, and again B2, and again here B2. So how the metadata will be stored for this data? Block 1 is stored in data node 1, data node 2, and data node 5. Data node 1, data node 2, data node 5. Block 2 is stored in data node 1, 3, 4, and 5. Data node 3, data node 4, and data node 5. Are we clear on this? How the data is stored? Yes. there is a rack awareness algorithm which decides which block has to be stored in which node. That is the next step will be discussed. Okay. Hmm. Hmm. Huh. Means it assumes that whenever it is getting a heartbeat signal means that data node has no issues. It is running correctly. So for the data node, it can assign blocks. The main reason for heartbeat signal is to make sure that data node is up and running. Okay. It tells the name node that it is up and running. Right? Okay. Now, yes. 3. You can change it. Suppose this is 1 GB. Let us assume 1 GB each data node size. 1 GB equals to how much MB? 1024 MB, right? 1024 MB. So 1024 MB divided by 64 MB is how much? 1024 is 1 GB, right? 1024 divided by block size, default block size is 64. Let us assume 16 blocks means a data node can exactly store 16 different blocks, right? Now your answer, the answer to your question is, out of the 16 blocks, already 3 blocks were stored. Now the data node from the block reports, the name node understands that okay, it has the capacity to store up to 13 blocks only. Whenever it is reaching 15 blocks, name node alerts that okay, the disk is almost full. So we have the flexibility of adding new nodes to the cluster. That is again new activity. Whenever your disk is full, you need to add a new node to the existing cluster. That is called commissioning. Commissioning and decommissioning of nodes, that is another topic. That is too early to discuss about that. Okay. So name node will decide depending upon the block reports and heartbeat signals how to assign the blocks to the available data nodes. Okay. Yeah. Why name node will delete? Tell me. Who will tell name node? Until and unless you tell, name node will not do anything. The client is asking to store, so name node is giving. If the client is asking to remove, it will remove. Then you can remove, right? All the 3 copies will be deleted. Yeah, you can remove. Can anyone come here, please? Now let us do these exercises with Hadoop FS commands, okay? Where you can understand. Come, anyone. Just. This is plus button. Yes, now.
in previous application is three. So in this case, block data for which number?
Once check this example, you will understand. Now switch user SU space. We'll do with the example, then you will understand. SU space hyphen space HD user. Enter Hadoop. Now what is the command to check whether your cluster is up and running? JPS. Your cluster is not running. So what is the command to start the cluster? Now once data node, and if you have any issues in data nodes, you can directly go to the logs file. Use the local Hadoop logs to check whether. Now you have all the file daemons running, right? Go to the Mozilla Firefox. What is the name node WI port number? 50070. Okay. Localhost colon. Localhost colon. Localhost colon. Localhost.
This one.
Notepad and check whether it is or not. This notepad, this notepad. Control A, Control B. Copying the page of. Now what is the first command? LS. Normally what LS is like?
Listing the file. Yes, sir.
LS space hyphen. This is normally what you do in a Linux command.
List the content. List the content that match the specified file pattern. If path is not specified, the content of user current user. ID user.
The same can be reflected here, right? Directory, name, modification time, permissions, order, group. So you can either get the Hadoop file system command from terminal or from web. Okay. What to do is copy this functionality and again the list command help. Right click, copy, notepad. Simple way to learn is first help command, paste. So we have taken the help command and one example. What is the next command? LSR. Now if you go to the terminal here, app is the directory, right? Second mention. Clear? Okay. Now if I click on the app, under app again, what do you see? Hadoop is there. This is also directory. Under Hadoop again,
PM.
Is only giving you the parent directory. So there comes the next command. What is this? LSR, recursive list. Means what are all subdirectories present in that main directory, it will display. FS is the prefix, hyphen help, LSR. What does it say? Recursively list the contents that matches specified file pattern. Behaves very similar to Hadoop FS-LS, except that now Hadoop FS / recursive list of parent directory. Now you see here, you have app. Under app again you have app Hadoop temp, app Hadoop temp mapped, app Hadoop temp system, etc. etc. That is, if you see app Hadoop temp mapped. So either you can browse the file from this web UI, or else using the LSR command / you can get the entire file system. So there is no CD, no present working directory available in Hadoop. The only commands to list the file system is either ls command or LSR, right? Okay. Clear, right? You know ls and LSR, madam? Clear? Yeah. Now what's the next command? Do you have mkdir in Linux, right? So LSR also. Once do the example, its syntax, right click, copy, and then you can paste it here to make sure that you are Control V. Now, you have the next command called mkdir. What does mkdir do? It makes directory, right? So let us see how to make a directory in Hadoop as well. Go to the Mozilla Firefox, go back to DFS home, browse the file system. App is there. Suppose I want to create a new directory. Again, new Hadoop fs -help mkdir. What does it say? It creates a directory in specified location, right? Now Hadoop fs -mkdir. Suppose I'm giving a name. Wait. Now, first of all, we'll browse in web UI and then we'll come into. Please check. See, don't do while I'm telling. Okay? Please check this. Okay? Go back to DFS home, browse the file system. Now, what is the new directory you see here? Earlier, there is no user, right? So, click on the user. Under user, SD user. So, where is your AVD directory created? User, current user. So, user, SD user is the default path. So, if I want to test here, Hadoop fs is the prefix -ls / app user. But I want to get the recursive list of directories. Hadoop fs -lsr. So if you see under user, you have user SD user, SD user AVD. Suppose I don't want to get the entire file system. I want to get only the default location. Demo this /. What is you are getting? Only default path, user, SD user, AVD. Am I clear or any questions? Am I going fastly or what? Huh? I'll slow. Now you understood, right? Now Hadoop fs -mkdir avd1. Where do this directory created? User, SD user, Hadoop fs -lsr. You see under user, SD user, you have a avd1. Go to the Mozilla Firefox, refresh, a new directory will be created. Right? Now, for example, Hadoop fs -mkdir /avd. Now, what is the difference you see now? Tell.
AVD under AVD. AVD will create inside AVD.
Okay. Subdirectory. Okay. Separate tree directory, not subdirectory. Separate tree directory. Now here you see, if I do avd1, avd2, it will be created under user SD user. But I have given /avd, right? Means it will consider as one tree directory, separate tree directory. Like app, user, avd will be also created as one separate tree directory. One second. Suppose Hadoop fs, what's your name? Huh? CH. So I am creating Chaush directory separately. Okay. Now Hadoop fs -ls. You see, this has been created as a separate tree directory. Suppose if I create this directory without /, then user SD user means this will be considered as user SD user Chaush. Understand the difference? Normal Chaush and /. Normal Chaush means it's the default path, user SD user. If you mention /, means it will be treated as a separate tree directory, right? Don't smile. Okay. So creating directory is fine, right? Okay, great. Now we will be entering into the yellow t-shirt. Now we will be entering into the Hadoop distributed file system, how the files will be divided into blocks. Now in the browser, if you see, go back to the DFS home, browse the file system. These are the three directories: AVD, app, your name, and user. User is default path, user, HD user. Under user, HD user, you have two names, AVD and AVD1. These are all directories. We have not yet worked with files till now, okay? Now, let's see here. Which command is this one? Enter. This is again Linux command. Now, what I do is, I'm taking a very small file, which is closely 89 bytes, 0.08 KB. If I want to store this file in Hadoop, how much size it will be allocated? One block only, but 0.89 only it will be given, right? But it will be considered as one block. Not take 64 MB. Out of 64 MB, 89 bytes only it will accept, but it will be considered as one block. Okay. Now, how to place this file from local file system to Hadoop? Huh? Sudo means every time it is taking root privilege. We have not given root privilege. We are added into sudo's list. Sudo's list. Like root privilege, but it is not a root. Whenever you are giving sudo, this SD user will take the root privileges from the root user. Super user. Okay. Following what I'm saying? For example, if this is okay, now this is ls space hyphen ltr. Now here you see, if I do sudo, it is taking root privileges. If I do nano sample file 1, as it is home SD user folder, it will do. Hello all, Control X, Y enter. Here if you see ls hyphen ltr, the username is SD user Hadoop. Whenever I am taking sudo privileges, the permissions were different. Normal nano means it is getting its own privileges, right? Understand the difference. Now I have a file, sample file. I want to place this file into HDFS. So how to do that? Now I have a local file system called Ubuntu. This is Ubuntu. And this is my Hadoop distributed file system. This is known as local file system. This is known as HDFS. What is the difference between local file system and HDFS? In HDFS, you have 5 daemons, master slave architecture, you have replications, you have blocks and everything, right? Now, there is a file called home HD user sample file. This file, once placed in Hadoop, what happens? This file will be converted into a block in HDFS, right? So how do you do that? We have two commands called copy from local. Put command, it will put the file from local file system to your HDFS, or you can also use copy from local, means copy from local file system in simple words. You have this notepad, right? So touch mkdir is also done. What is this command? Put and copy from local, right? So I'll be using now put command. Hadoop fs hyphen put or hyphen help put put. Copy files from the local file system into fs. Hadoop fs hyphen put home hd user. What's the file name? Sample file. In HDFS, you have different directories. You have a default directories under user HDFS. First of all, we'll place into default directories. What is the default directory? AVD and AVD1. So let us mention AVD. AVD means, in simple words, okay, instead of giving all this, I'm just giving AVD. Wonderful. Now, if you go here, click on the AVD. What is this? What is the size? 85 bytes, closely 9 KB, 0.09. What is the replication? Block size means it will not take 64 MB. Total block size is 64 MB, but its actual size is 0.09 KB. Modification time, the file system permissions, owner group. You can see the data, right? Hello all. Welcome to HDFS commands. HDFS is storage, name node is master. Is this the file you have placed, right? All of you. The same thing you can do in terminal as well. So in order to list the files, Hadoop fs -ls /. You have the only main parent directories. Subdirectories, I don't give / because it is a default directory. Now where is your file? Dash rw dash r dash dash r dash dash rw dash r dash dash r dash dash. Next, one is nothing but replication because it's a single node. HD user super group. Who is the user? Owner. HD user super group. Date and modification 2022, today's date 2104. 210422 64 means whatever data you are getting here, you can simply browse that in web UI as well. Now, how to read a file? Cat. In HDFS also you have the same command. For example, cat. If I want to read this file, Hadoop fs -cat. Give this file name. Are we clear? Okay. Any questions? You have placed a file. Yeah. We are placing the file from local file system to HDFS. Touch command is there, right? You are creating in local. There is also one command. You can directly create a file in HDFS. That is later I will tell you. Now we are placing the file from local file system to HDFS. Copy from local also does the same. Hadoop fs -help copy from local. Sorry. What does it say? Identical to the put command, right? So now what I do is Hadoop fs -copy from local home HD user sample file. If I try to keep the same file to the same location, what happens? Who said overwrite? Hadoop is a write once, read many times. Just now we discussed, right? So we are not appending right. So this will not allow. Target AVD sample file already exists. So it is not allowing you to write to that file. Until and unless there is another option called append to file. You mentioned that Hadoop will not allow you to write to that same file. Okay. Now I can write into different location. Suppose AVD1. Go back to DFS home, browse the file system, user, SD user, AVD1. Now it's the same file, but with different location. User, SD user, AVD1. Right? You can place the same file to different locations, but not to the same location. Now say for example, go back to DFS home, browse the file system. This is the directory, app is there, right? AVD is another directory. So what I do is slash. This will be now placed into this which directory? AVD. So you now have Hadoop FS -ls or /. Now you can see under app Hadoop temp, you have under AVD, you can have a sample file. Creating the directories mkdir, placing the files, either put command or copy from local. Clear right now? Now let's do the vice versa as well. No difference. The both are same. Either you can write copy from local or put command. They have designed like it means if you want to keep more number of files, you will use copy from local. Simple put means easy to remember, right? So you can use like that. No other specific reason, right? Yes, you can. You can also do that. For example, slash your name. I'm giving the file. Okay. Hadoop FS -ls /. Now you have this AVD, right? Under AVD, now you can see two files. So you can give the same file name, or else you can give your own specific customized file name as well, right? So copy from local, put command, you are aware. Now let's do the vice versa of that command. Now you will be getting the data from HDFS to local file system. Earlier we are putting the file to HDFS. Now we are, so the opposite to put is get. Here we are copying the file from local. Here we are copying the file to local. So copy to local. Okay. Go back to the terminal. Hadoop FS -ls /. If I give LSR, yes. Now if I give LSR, now there is AVD sample file and you have user HD user AVD sample file and everything. Now my requirement is to get the files from HDFS. Let us take that this is a file, default file location, user HD user AVD1 sample file. I want to get this file. So Hadoop FS -get. One second. Hello. Good morning. Yeah, who is this? No, I'm in a meeting. Can you call me after 1 hour? Yeah. So Hadoop FS Hadoop FS hyphen get, give this file location. Clear? Okay. Now Hadoop FS hyphen get, you have a sample file at AVD, right? AVD slash sample file. Suppose I want to get this file to local file system location temp folder. So from HDFS, I'm getting the file. In local file system, there will not be any blocks and everything, right? What is the need to get into local file system is sometimes you need to attach the logs from desktop to the application team owners. So you need to get the logs from HDFS to your local file system, and from local file system you can send those logs. Okay. Now where you need to check this now? Where you have to check this in which location? Where? What is the source here? Tell me. Source. What is the source? What is the destination? So where you need to check? Temp folder, right? Yeah, local machine. So what is the command? ls no. cd temp ls space hyphen ltr. You can see a sample file here. Likewise, you can download. I mean, you can get the files into anywhere. For example, OPT or else home SD user. For example, any name. Say for example, any name you can get it. Now, where you need to check this? Home SD user. Now you see there is a file name has been modified. In this way also you need to check this. I mean, use this get command and copy to local commands. Get and copy to local does the same thing. Are we clear in it? Very, very important.
When we are getting it back in the normal local file, so we have to copy by block by block.
That file is there, right?
Yeah.
That file is divided into blocks. 100 MB file is you're taking. So 100 MB is divided into how much? 3 blocks, right? In our case, one block, one B1 and B2. So that B1, B2 is combinedly coming to this path, local file system, right? Now, what are the commands till now we have discussed? ls, lsr, mkdir, put, get, copy from local, copy to local, cat command. Now, there are few more commands as well. You see, count command is there. Copy, move. What does copy do? It will copy the files from one location to another location. In Hadoop also you have the Hadoop FS hyphen help copy. Remember, put command, get command used to get the files from local file system to HDFS and vice versa. Copy is used to do within the same either local or HDFS. Now we are doing Hadoop, right? So Hadoop FS hyphen LSR, for example, space forward slash. Now say for example, I have a file called AVD1 sample file to be copied to say for example slash app. I will copy this file to this location. So Hadoop FS hyphen copy this location source. Here both source and destination are in the same HDFS only. Copy, paste. For example, you can give anything. This is the directory, right? Your name. Okay. Copy, right click, paste. Now Hadoop FS hyphen LSR forward slash. You will be having the two copies, right? Two same files, AVD1 sample file and again these files. So copying is what? Control C, Control V. Let us do move. Control X, Control V. Hadoop fs hyphen help MV. Move files that match the specified file pattern. So again same. Hadoop fs hyphen move. Copy this file. Now what happens if I do a move command? The source file will what happen? Tell me. What happens to the source file? Deleted. In other words, it will be renamed, right? Right click, copy, right click, paste. Now let us move this to some other location. For example, there is /avd is there, right? We shall move to that location. /avd. What does it say? Fail to rename this user as the user avd1 sample file. Why? Because you have the same file, I guess. I think so. avd1. 1 second. avd or avd1 I have given. 1 second. avd sample file is there, right? Let's do one thing. avd / sample file 1. Done. Why? Because already we have the same file, right? So it is not taking. Hadoop fs hyphen ls or /. Now this file should be deleted, right? Last file should be deleted. Enter. Now you see, only user user avd1 is there. Sample file is not there. So in today's session, what's the move is done? Can anyone open the Cloudera? Cloudera, can anyone open Cloudera? Otherwise, wait. Let's do some other. There is a count command is there. Du is there, dus. What does count do in normal Linux file system?
In lines, words, or
COU and for example, clear count space hyphen help. Count. It normally counts the number of files or directories. Hadoop fs hyphen help count. Wonderful. What does count say? Count the number of directories, files, and bytes under the paths. Now, for example, Hadoop fs hyphen lsr /. Now, he says there are so many directories, files, right? I will use count command. Hadoop fs hyphen count. You need to give the 3 directory. So there are 12 directories, 6 files, and total size is 449. Means 89, 4. All these bytes. Okay. Total 449 followed by this local file Hadoop file system path. Otherwise, you can also do count, for example, app folder. So under app folder, how many directories are there? How many files are there? It will display. Can we proceed or stop? If your faces are looking very. I can take 1 more hour, but you tell. If you keep your faces like that, it will break. आधा घंटे का break. Will you go home and come or what? 10 minutes break, okay? 12:45. 15 minutes. Okay? Metadata means data about the data. How many files are, for example, you have an Aadhaar card, right? Aadhaar card Aadhaar card is there. Your Aadhaar card number is your metadata. All the information, your name, age, and everything is actual data. Your Aadhaar card number is your metadata. Correct. Metadata.
But the local nodes is not opening.
You have started the cluster.
Yes, sir.
Where is name node? Where is name node? Where is name node?
Every time I have to
Actually, if you start icon, it should start. Name node. Now you go. Please leave my phone, okay? If you're not going, you're staying. You go, you go. Pick the phone. I'll come, I'll come. I'm going to the
Using forward slash after ls different LTR. So when we have to use forward slash and when not.
If you want to get the default path, don't use forward slash. If you want to get the total file system, use forward slash. File details means what is default file? Default file or which file? Means no need a forward slash. Then you can give that. Hadoop FS unless and then path.
Sir, getting error at this email.
You have not given Java JDK, you have missed a forward slash. You open your Hadoop-env.sh. Yeah, what's your problem? In the EDC environment, you need to keep it right.
In the Hadoop user
In the ETC environment, you need to paste that file, right?
अरे चलो यो
Hey, and we're here, right? Make it fun. What's the password? Here is the start box. What are you saying about the videos, ma'am? What is the video? Not normal video. This is the first step we will doing. You have the video and you're doing mistakes means home. Go. Password? Any pass your machine? Yeah, please drop them fastly. Export, right? What is this export? The Java first you're not doing properly. Okay, okay, settle yourself. Once this is in. What is that? What is this? What is this? Caused by mapprint-site.xml.
Yes, sir. I changed it twice, sir.
The processing target not is not allowed. Hey, don't give any. Don't change anything here. I told you, right? But SSH you have done not done properly. One second. What's that? Start the cluster. Start the cluster. JPS should be running. Name node should be running. What's the problem? Yeah, browse the file. First. There is data node. Not working means you have not given the directly permission. Please check that. What's your problem? Start the cluster, madam. Where is name node? Name node is not available. After starting, you need to check whether your
Payment is running properly or not. Memory is not a device. You need to check PDF. Hey. You need to check the meaning of block. Okay. Date is block. 01207. The same app will come directly to the you are not given the full permissions. DFS full permissions I told you. Please sit, please sit.
Yeah. Sit down, sit down. Okay. Now, choice. Don't laugh. Okay. Okay, see. Till now, what are the commands we discussed? Copy, move, right? Now, in Linux or in Ubuntu, if you delete a file, it will be completely deleted. But in Windows, if you delete any file, you can recover it because there is a feature called recycle bin. In Hadoop also, if you see Hadoop fs -lsr, right? You have a file, right? This is a file, user is the user sample file. Now, if I Hadoop fs -help rm, like Linux, rm also works in HDFS. Now, if I do Hadoop fs -rm, if I remove this file /avd/sample file, what is the output you see? Deleted. Now you cannot get that file again. You cannot recover that file again. You cannot recover that file again. Suppose this is a very important file, and by mistake, by human mistake, you have deleted this. So how do you recover? You cannot recover, right? So for to avoid this accidental deletion of files, we have a concept called trash in Hadoop also. By default, this trash feature is disabled. We need to enable this trash feature. How to enable? What are the important configuration files? core-site.xml, mapped-site.xml, hdfs-site.xml, Hadoop env, right? Now, if you do cat or sudo nano core-site.xml, just copy this property. Most of the people are giving spaces here. They are copying the property above. Don't do any mistakes. In between the configuration only using downward arrow, you need to paste the content. You should not give any space above XMLs and everything. Okay. So right click, copy, and I'm doing, if you see, after this property using upward arrow, downward arrow only, I'm pasting this property. Now I'm going to this property name. I'm giving fs dot trash dot interval fs dot trash dot interval. By default, this trash interval will be 360 minutes. Means how many hours? 6 hours. But for our understanding, I'm just reconfiguring to 10 minutes. Means for every 10 minutes, the trash checkpoint will run. Here you can give enabling trash. Enabling trash future or trash fault. You have added a new property to the configuration file. Remember, very important interview question. If you do any modifications to the configuration files, you need to restart the cluster. Then only name node and other daemons will be notified by this change. So I have added a new property called trash to this core-site.xml. Control X, Y, enter. JPS. Restarting is nothing but stopping and starting, right? I'm stopping the cluster. And again, I will restart the cluster. Most of the people are failing to do that passwordless SSH, so that they are getting these issues like password issues. That is one major issue. And you are not configuring Java properly. First of all, check the Java path, configuring etc environment. Java should be given in bash or C and Hadoop hyphen. Okay. Now again start the cluster. JPS. Here I just want to make sure that I will show you one thing. Go back to DFS home. Now what does it say? Safe mode is on. Safe mode will be turned automatically in 27 seconds. Again, refresh. How many seconds? 15, 12, 10, 9, 8, 7. So by default, after a restart, name node will be in safe mode for 30 seconds. What is this safe mode? We will be discussing soon. But make a note of this. Safe mode, 30 seconds after restart. Okay. Safe mode. Name node will be in safe mode for 30 seconds after restart. Now, now I have added a new property, Hadoop FS -ls or enter. Let us see any files are there. There are no files. Hadoop FS -lsr/. Now you can see there is a file called /avd/sample file. Now let me delete this file and see what happens. After enabling trash feature /avd/sample file. Now what do you see now? Earlier it says that deleted. Deleted means gone. Now it is saying that it is moved to trash. So after enabling the trash, what happens? Under the default directory user, SD user, there is a directory called dot trash will be created. Under dot trash, there will be a current directory where it tells the, for every 10 minutes, I told you, right? There will be a checkpoint. So a checkpoint will run for every 10 minutes. Now we have deleted the file, AVD sample file, right? That file will be stored in this. If you see, CLER clear, Hadoop fs-lsr. Now you see user SD user dot trash. Under dot trash current is there. Under current, the original file path is preserved. If you see, what is the file we have deleted? /avd sample file, right? Once the file is in trash, you can simply recover it, right? Hadoop fs-cp from this location. Right click, copy, right click, paste, space. I can give my original location so that the file will be again recovered, right? Right click, copy, right click, paste. The file that I have deleted is in trash folder. Now from trash, I am copying this to again to my original location. How long will be this in trash means there is an expunge command. You can delete all the files that later we will discuss. Okay, this is too early to delete everything in trash. Now Hadoop fs-lsr /. Now you can see /avd/ the same file can be recovered, right? Everybody, you have deleted and then you have recovered. So this is the main use of trash. The 10 minutes means for every 10 minutes there will be a checkpointing will be running. We shall see after 10 minutes. Okay, 12:59, right? At 1:10 we will see what happens under this current folder. Let me show you this. Now here you see under trash there is a current, right? Where is this? Yeah, under trash there is a current, right? After 10 minutes, let's see what happens. Okay. Now, how do you delete a directory in HCF Linux file system? RM. In Hadoop also we have Hadoop fs-rmr help rmr recursive remove. If you want to remove all directories which match the specified file, equivalent to Linux command rm-rm. Now there is a skip trash option also. If you mention this skip trash means it will not go to trash. Avoid trash and completely delete. For example, Hadoop fs-ls/. Now say for example, I want to delete this directory rmr. Sorry. Okay, paste. Now recursive removal of, now here you see it is moved to trash. Even the directory is also moving to trash. So in that condition, what we do is, if I want to delete this AVD with, for example, LSR in the trash folder, you can see this directory name again. You see, current. If you see the directory is there, right? Means directory is also going to trash first. So you can easily recover, right? Right. Now, for example, I don't want my directory Hadoop fs-ls/. I want to delete this directory and I don't want this go to trash. So what I do is Hadoop fs-skip trash -rmr/avd. Skip trash in small letters, I guess. One second. Hadoop fs-help rmr Okay. Hyphen skip trash trsh/avd. Now what does it say? Deleted. So it is not going to trash. You are telling that no need of storing it into trash. So in that case, you need to avoid, you need to use skip trash. Clear and everybody? Now Hadoop fs -ls /. du df disk usage commands, df disk free commands we have in Linux, right? Same commands also we have in Unix. For example, dus Hadoop fs -help du. Du path show the amount of space. So simply Hadoop fs -du. You can give the specific path or so under app there is only 4 bytes. Under user there is 170 bytes. How you can say? For example, go to parent directory. Hadoop fs -lsr/. Now under app, if you see under app, what is the file says? 0000004. So under app, only 4 bytes is there. This is what it is saying above. If you see under app, there is only 4 bytes, which is 4 bytes. Now under user, it is saying 178 bytes of data is stored. So let us see what is there in user. So 89 plus 89, 9 plus 9, 18, 1, 8 plus 8, 16 plus 1, 178. So 178 bytes is stored under user. In this way, you can get the disk usage for a particular file folder. Like suppose if I want to get a complete 178 plus 4, how much? 182, right? Hadoop fs -help dus. Hadoop fs -dus. Enter. It will give the total combined disk usage of the file system. Du means it will give directory by directory, path by path, how much amount of disk space is used. Whereas dus means complete disk usage of the entire file system in one line. Right? Now another very important command is set rep. This is interview question. What is the default replication in Hadoop? It is a production cluster if 3 nodes are there. If it is a single node, what is the replication? 1. Why? Because we can store only 1 copy. No 2 same blocks will be stored in the data node, right? If there are 2 data nodes, how many copies you can store? 2. If there are 3 data nodes, 4, 3 only. Default is 3, right? If there are 5 nodes, 10 nodes, 100 nodes, 3 copies only. Until and unless you say that the replication is 5 or 4. Hadoop maintains 3. Now, say for example, Hadoop fs -lsr. Let's say that there is a file. There's no file here, right? Hadoop fs -put Hadoop fs -put home is the user sample file to, for example, avd. Okay. Under avd there is a sample file. Now Hadoop fs -lsr. Under avd you should see there is a file, right? What is the replication in here? 1, right? Go back to parent directory. Go back to dfs home. Browse the file system. Now as user, sd user, trash. See if you see, there is a timestamp. Earlier there is a current, right? Now there is a timestamp 2204. Okay. Likewise, it will. Now let's go back to our normal setrep command. User, HD user, AVD is there, and for the sample file, what is the replication? Now, setrep command will enable us to change the replication factor for a specific file only. Specific file, important question. If you want to change the replication for entire cluster, you should change in hdfs-site.xml. dfs.replication, one value, you need to change it to 2. Here, if I want to change for this simple file, sample file only, the command will go in such a way that Hadoop fs -help setrep. Set the replication level of a file. Hadoop fs -setrep. What is the file name? avd/sample file, right? Sorry. Sample file, right? Okay, what's the value it is asking? I want to make 2 copies. Not /a video, normal AVD, I guess. If you see normal AVD means user HD user. Replication 2 set for user HD user AVD sample file. What is the replication here? 1, right? I'm refreshing 2. Now, let me check this whether it is reflected in Hadoop fs -lsr. If you see, the replication is set for 2. Now here important question you need to ask. You told me that name node will not store 2 same blocks in one data node. But here you are asking to set 2 copies, or you are asking to store 2 copies in one node. How is it possible, right? For that reason, ideally this command works, but physically the name node will check for another node. What is this? Number of under replicated blocks. 1 means under replicated means which is below the given replication factor. You have asked to store for 2 copies, but name node is storing 1 copy. It is looking for another copy to store, but it cannot store because it's a single node. So it is maintained as under replicated. The cluster is now under replicated. Suppose if I give 3, which is more than suppose 4, which is more than 3, then over replicated it will show. For command it will work. It says that okay, replication is set for 2. In production cluster it will work, but in a single node as a command wise it will work, but in reality it can store only 1 copy. The other copy and to store, but it is unable to store because it's a single node. So that's why under replicated blocks. For example, again I will give setrep 1. Again I'm changing. Let's see what happens. Now no issues, right? Everything is single block. No need of storing the same block in the same block. That's why no under replicated blocks. But if I give 2, it will say under replicated. You understand what I'm saying, all of you? Your assignment for today is, first of all, complete 1.x installation and follow this video. First, brush up your Linux commands. First, copy Hadoop fs commands like this and start practice. Check the video first for 1 hour or 30 minutes what we are doing. Once I completed 1 command execution properly, you understand. Now you try. It's not like that I give Hadoop fs, you also type Hadoop fs. Not like that. Hadoop fs, what I'm doing and what I'm saying. Understand. Now you do that. If you're getting the same, okay, then why you're not getting, again, read my instruction. Okay, all of you. Chalo. Thank you. Thank you all. Yeah.